there's lots of different ways to talk about and to notate differentiation, which is this process we're going through, finding the gradient function, okay? Even there, I'm throwing out a lot of words at you. So I'm going to try and break down a lot of these terms so you've got it all in one place, so that when you see it said different ways, you don't get too confused, okay? So let's start, right? You'll see this. If f of x is a function, right? Okay? Then f dash x, right? I say that as f dash x, okay? Or just f dash, right? What that means is, tell me the gradient function, which we've been finding by first principles. Okay? Another name for the gradient function, you might have heard me say a few times, is the derivative. Okay? Because it comes from that function. So it's derived from. However, just to make things more confusing for you, okay, the process of going from f to its derivative, okay, this process, is not called deriving. Stupid mathematicians and their use of English. It's called differentiating. Okay? So to go from a function to its gradient function, to go from f to f dash, we call that differentiating. Okay? Now all of this is in terms of f's. Okay? Usually when you get a function, we say y is equal to something. Right? Like say y equals x squared. Okay? So this is, again, that's a function. Right? But when you want to talk about its gradient function, there's another way of describing it. There's no f's here. Right? So what would I say? Gradient is all about rise over run. Rise over run. Okay? So therefore, gradient, right, is rise over run. Look up at this one because this is important. Okay, rise is really just a way of saying how is my vertical distance changing? How is my y value changing? Right. So rise, instead of saying that, I could say the change in y divided by the change in x. Okay, but this is very long. So instead of saying change in, we say d. Actually, we mean delta, like Greek letter. You see this in science as well. In like a chemical equation, you've got some chemicals and then they turn into something else and there's a reaction, a change in the middle, right? That's just the capital D in Greek, delta, okay? So a change in y, we call that dy, okay? And the change in x we call dx. Right? So this is another way of saying the gradient function or the derivative, okay? It's the same thing. But let's just make this a little more, right? This y, right? It's actually equal to something in terms of x, okay? So I can write this as putting that y out over here. So y is the function I'm differentiating, okay? And d on dx is the process of getting the gradient function, differentiating, okay? So it's a bit like, you know, when you see sine of 30 degrees, okay? 30 degrees is the thing that you're doing an operation on, and sine is the operation, okay? Well, if you want to differentiate y, you put a d on dx at the front, okay? So for instance, I could write d on dx of x squared. That would mean differentiate x squared. Okay? Now, this is a really crucial one because lots of people make this mistake. I know I did back when I was in year 11. When you're trying to work out the derivative of something and you're just writing down your answer, okay? The question says, you know, differentiate or find the gradient function, and then you've got a whole bunch of examples, right? Okay, and say the third one is x squared. Okay, so you get down to writing your answer, and you say, well, the way to write a derivative is this, right? So you write d on dx, right? It's better than saying dy on dx, because there is no y, right? But it also doesn't make sense on its own. It'd be like saying sine on its own. Sine of what? It's an operator. It has to do something to something. There has to be an object here, right? So you'd have to really say d on dx of your function. 2x.
Don't you have to have brackets around the x?
Okay. Strictly speaking, when you've just got the one term, you don't. But we put them in to clarify. Okay. So, one more thing I want to put down. When you're finding the gradient function, often they don't want the function, they actually want the gradient at a particular point. Okay? So for instance, if I want the gradient at x equals 0, okay? Instead of saying f dash x, they'll say f dash 0. Okay? That means, what's the gradient when x is 0? Okay? So all these different ways to write things, okay? You want to be watchful for them. And even though we've all been talking in terms of y's and x's, in a sense it doesn't really matter what letters you use, right? So for instance, you could have like a, let's see, a position function in terms of, say, your velocity. Position, velocity. Okay? I can still find the gradient function of this. I can still differentiate, but it won't be dy on dx. Okay? It won't be dy on dx. It'll be dp, that's the thing out the front, right? On d, well, what's the other variable? dv. Okay? And that'd be 6v. Okay? So what we're doing here versus what we're doing here, let's see here. Where did I put it? You're differentiating x squared here with respect to x. X is the variable you're paying attention to. Here, I'm differentiating p with respect to, there's no x's in here, right? I'm differentiating with respect to a different letter, a different variable. In this case, v. Okay? Sometimes you see that this abbreviated to this because people get sick of writing with respect to. Okay? But there you go. I admit that's very confusing. There's so many different ways of writing it. The reason why there's so many ways to write it is because lots of different kinds of people, mathematicians, scientists, engineers, and so on and so on and so on, they all want to use this same idea, but in all their different fields, they write things differently. Okay? So therefore, you've got different notation that comes up because of